we want to handle data securely. And then we look at our application. And then we decompose that application into components and subcomponents so that we can start to really look at the security features that we can put in place. And then we're going to, for each subcomponent, we're going to start to identify the threats against that component. And then finally, we'll identify vulnerabilities, which are simply unmitigated threats. We haven't put any control in place, or we don't have anything that's going to protect us from that threat. And then, hopefully, we put controls in place that will help us mitigate those things. So here, I'm not going to walk you through this entire table, but essentially, we have multiple steps here. And the first step is just to identify our security objectives. And in order to do that, we take in our business requirements, our security policies, compliance requirements. We think about all these things, we kind of put them into a bucket, and we have a big meeting. And out of that, we have our key security objectives. And out of this, a key security objective might be that we're going to be HIPAA compliant, because we want to sell our software to other companies that will store medical data in our application, right? And that might be one of our key things, because if we don't do that, if we're not HIPAA compliant ourselves, we have no chance of ever selling to somebody who wants to store medical data. That would be, they would say, well, are you HIPAA compliant? And you say, well, we were going to do that, but we didn't. And they say, well, I'm sorry, we can't use your software, even though we'd love to. And so we do this for multiple steps, right? We create an application overview. We decompose our application down to trust boundaries and entry points and exit points and data flows. We identify those threats. We identify vulnerabilities using the threats that we haven't mitigated already. We take in those unmitigated threats. We take in some common vulnerabilities for our system. And then out of that, we have this vulnerability list, which actually is really useful for developers and testers to understand, what work they have to do in order to fix these issues. So threat trees sometimes look like this, right? So at the top, we have the threat itself. One level down, we have how the threat might be possible. So right here. And then at the bottom level, we have the actual activities that the attacker would do in order to realize that threat up there. So we're going to, hopefully, after we design these threats, we're going to redesign and eliminate those threats by pruning this tree at the bottom. And we're going to say, well, we're worried about somebody intercepting credentials during their transmission. So how can we protect our data on the wire? We're afraid that somebody's going to bypass the application UI to create a transaction. Well, how can we mitigate that risk? And after we prune that, we have eliminated this. And how do we do this? We can redesign, or we can add controls in place. We can use standard threat mitigations and things like that. And then finally, this is something that I think that we as engineers struggle with, is this last one: accept risk in accordance with our policies, with our organization's risk tolerance. We talked about this a couple days ago, where we were saying, well, big companies aren't going to do it anyway, because they're going to say, well, it's going to cost us $1 million to fix, and it's going to cost us $500,000 if the data breach happens. So let's just see what happens, right? And unfortunately, that's the way it is. You have to look at these threats and these risks and think about that in context of your own application and your own company. So best practices, we want to enumerate all the assets of value, consider the threats, think about confidentiality, integrity, and availability of each thing. So we generally put security in the context of data. And we think about how we want to keep that secure, how we're going to allow only the right people to see it, and how we're going to make it available when they need it to be available. So if any one of these three things fail, if we can't make sure that that data is what we think it is, we can't make sure that it came from who we thought it came from, or we can't make sure that it's available to the people that it needs to be available to, we're failing at security, and we need to make improvements. So for each threat, we're going to brainstorm attacks, and this is my favorite step, right? This is where we get to go crazy, right? We get to think about, well, you know, ninjas jump into our server room at night and attack our server. And we say, okay, well, that's a threat. We'll write that on the board. You know, somebody intercepts our key transfer on the wire. Okay, there's another threat. Somebody, we decide to use SneakerNet, and we're actually transferring keys on a thumb drive from LA to New York. Somebody intercepts the plane and steals the thumb drive, and they have our keys, right? So this is the phase where we get to go crazy. Now, all those threats, we're probably not going to mitigate every single one, right? I have yet to see the mitigating factor of ninjas attacking a server. However, you know, if your data was important enough, you may want to go down that path. And then we're going to identify success conditions, like how would that attack actually succeed? So after we have a threat model, we're going to use that threat model to create a test plan. And test plans simply validate the success or failure of that threat. So finally, I have a little checklist for everybody. And so first of all, no design should be considered complete until you've created and finished your threat model. Your threat model should be kind of like one of those checkboxes for a living document that starts early and continues all the way through your process. Once you understand your whole data flow diagram, follow those anonymous paths very closely. Those are the ones that are at highest risk. Those are the ones that are going to cause you some major headaches down the road. Every threat needs a security test plan. That means that you need to be able to validate or ensure that this test plan is actually going to be validating the threats. And then check for all information disclosure threats, right? We talked about information disclosure a little while ago, but essentially this is in the form of error messages, or other sorts of information disclosure as far as like data quality goes and things like that. So, yeah. So in design reviews, so in design reviews, our goal here is to assess our application in the context of security. So we're going to start very early, right when we're building these designs, building the architecture, and things like that. And then we're going to analyze that architecture in context of security. So the idea here is that we might be able to simply expose the high-risk areas early on and make mitigating put mitigating controls in place, or make changes in the architecture that would mitigate that altogether. A while ago, we were doing an architecture review for a client that was having a real challenge authenticating servers with one another. They were kind of not exactly a cloud server, but or a cloud computing type of system, but they had multiple servers all over the internet that needed to communicate to one another. And they had written all of this code and gone through all this process. And finally we're like, well, what about just mutual certificate authentication over SSL, right? Where we put two certificates, or one certificate on either server, and we validate those certificates, right? And we know that certificate has to come from that server. We know that certificate has to come from that server. And we start to assign data and things like that. And early on, we kind of prune that threat away. So being able to expose those high-risk design decisions early and make mitigating changes early is really important. Don't rely solely on your documentation, right? Not everything is documented. Who's seen a requirements document that is complete? Right, so like, oh, everything in my design doc is in the application. Everybody's got one of those, right? Does anybody have one? Okay, I didn't think so. So this makes it really important to talk to your experts, talk to your architects, your developers, your testers who really understand the application to get a good understanding of where your threats may be. Now, here I've enumerated all of the application vulnerability categories, right? So for a web application. So we have a category of input and data validation, authentication, authorization, and those kinds of things. And for each category, I've kind of enumerated a few potential problems. So let's say that we're talking about, take input and data validation, for example. Right? So with input and data validation, if we don't do it properly, we may be accepting some malicious data. And so that means that an attacker may be able to supply some malicious string in the text box, which could lead us then later to SQL injection, cross-site scripting, buffer overflows, format string vulnerabilities if we're writing in C or something like that. And the result can be huge, right? It could be arbitrary code execution. So we're going to go on, for each one of these vulnerability categories, we're going to enumerate these potential problems. Then once we have these, we can enumerate some best practices. So again, right, for input and data validation, we're going to simply not trust that data. We're going to validate, we're going to encode, we're going to make sure that that data is exactly what it should be. And by doing this, we can kind of prune out a significant number of vulnerabilities by doing proper input validation. Now, once we validate that input, let's say it's a username and password, we're going to do authentication. And then once we're authenticated, we're going to authorize people to access different pieces of data. And at each phase of these categories, we're going to try to make these best decisions. And then for each one, we can create a checklist of how to actually design a system that is secure. So for example, input and data validation, we have a handful of these checklist items. And so, you know, on the top here, we have all entry points and trust boundaries are identified by the design. And we follow down, we start to say, down at the bottom here, we have design does not rely on client-side validation. One of my favorite things to say is JavaScript is not a security feature, right? If you're relying on anything to happen on the client to validate or understand the quality of your data, you're failing at security, right? There's no way to make sure that your client is doing what it says what it's supposed to do. Worst case, I'll write my own client and attack your server directly, right? So, so we have this checklist and we go through and we say, okay, when we wrote the design, we assumed that all user input is malicious. We centralized our user input validation, check, check, check. And at the bottom, we can be reasonably sure that we've solved this category of vulnerability. And then we want to look at the design and the architecture overall. And I'm afraid that I'm running out of a bit of time, so I'm going to speed this up a little bit. But first, we're going to think about the deployment and infrastructure areas. We're going to think about the security frame, which is those same categories that we were talking about a little bit earlier. And then we're going to go tier by tier and say, okay, what are the threats against our presentation layer? What are the threats against our business layer or our data layer? And once we go through there, we will have assessed the whole system. In general, we can start making good decisions. One of the big things that we see a lot of people do is they either get bogged down by implementation details and they start saying, well, how can we do that? Or that's going to be challenging to do, or I don't want to code that, or something like that. Don't let yourself go down that path. Right now, we're just thinking about design, we're thinking about architecture and threats. This is kind of a very high-level thinking about security. The other thing is that people tend to want to create a perfectly secure system, despite the fact that perhaps the data isn't that important, right? So don't design a $100 security feature for an asset that's only worth $5. don't fall into the recency trap. And what I mean by this is that depending on what's new in the news or what's popular nowadays, you may want to say, like,